Alright, so we're on the second page of the review, and now we're going to look at ratio, proportions, and similarity. So ratio, proportion, similarity. Remember, ratio is talking about rational numbers. A ratio is a comparison of two values. It can be written as a fraction, or it can be written with a colon in between the two values. We've worked with both. So this one here, we have 15 over 22 equals x over 4. So when you solve a proportion, which is two equal ratios, when you solve a proportion, which is two equal ratios, you cross multiply. So I'm going to cross multiply. I have 22 times x, which is 22x, and 15 times 4, which is 60. Remember my little goofy thing, cross multiply, make your butterfly. So then we're going to throw the paper on the floor because that's how I roll. And I'm going to divide both sides by 22. So when we do 60 divided by 22, I do not want to think tonight. So you end up getting 2.72 repeating. So x is actually equal to 2.7. We'll just round to one number. And that's how you solve that particular proportion. Now let's look at this proportion. Same thing, guys. Two equal ratios. Cross multiply, make your butterfly. But be careful here. Whenever you have proportions like this and you have multiple values, I caution you to put parentheses around any binomials or terms that have multiple, or expressions that have multiple terms. So we have 7 times 4x plus 6 on one side, and we have 9 times 6x minus 4 on the other side. Now it's just a simple matter of algebra. If you forget those parentheses, you're going to be sunk. So 7 times 4x is 28x, 7 times 6 is 42, 9 times 6x is 54x, we're distributing, and 9 times negative 4 is negative 36. Again, now it's a matter of simple algebra. Let's get all of the variables on one side. I'm going to choose to subtract the 28x to this side. So I've got 42 is equal to 26x minus 36. Okay? I hope I'm doing this math right because I'm half asleep when I'm doing this. But anyway, so now I'm going to take the 36 and I'm going to move that guy over here. So I'm going to come up here so you can see this a little bit better. So I've got 78 equals 26x. Isn't that handwriting beautiful? 78 equals 26x. So now I'm going to divide both sides by 26. And I believe it's going to be 3, but again, let me check my answer, because if I'm going to be on YouTube, I want to make sure I have the right thing. Yes, x is 3. So that's your answer. So that's how you solve the proportions. You cross multiply and then use the algebra. Now let's move over here. It says the polygons in each pair here, the polygons in each pair are similar. Okay, they're similar. That means that the ratios of all their sides are equal. They are proportional. That means there is a universal scale factor that we used to take this one and make it this one. So what we're going to do is we want to solve for x. So I know I'm going to use these two sides. So I'm going to set up a proportion. X plus 9 converted to 20. The same way 32 converted to 40. What did I do to get from 32 to 40? Because I did the same exact thing to get from x plus 9 to 20. It's going to give me the same ratio. And look where we are. We're back at that cross multiplication piece. So I've set up my proportion. So I have 32 times 20. Again, I don't want to think. I think it's 640. I don't want to think right now. So it's 640 is equal to 40 times x plus 9. There are those parentheses again. And let's draw our butterfly, because that poor butterfly is warped. And let's continue on. So I'm going to distribute. So I have 640 equals 40x plus 360. And then I'm going to take the 360, subtract it from both sides. Yikes. And so I get 280 is equal to 40x. And then when I divide it out, I'm going to divide both sides by 40. So x is equal to 7. Now let's check it out. What is 7 plus 9? 16. So does 16 over 20 give us the same ratio as 32 over 40? And if you look at it carefully, it does. 32 over 40 reduces to 16 over 20. They both reduce to 4/5. So that means that the first one is 4/5 of the second one. The scale factor actually would be 5/4. Okay. All right, so let's look at number 10. Number 10, again, we're all similar. So we went from 15 to 18. So what did we do to go from 4x plus 11 to 42? Now remember, just as a side note here, when we're trying to do scale factor, you'll put the image on top and the pre-image on the bottom. And I probably should be doing that right now because it's the best thing to do. It doesn't matter here when you're solving proportions, but when you're looking for scale factors, it does matter. So it's always image divided by pre-image. But we're just solving a proportion now, so it doesn't matter. We're just looking for a missing side. We're not looking for a scale factor. So I'm going to cross multiply these guys. So I've got 15 times 42, which is 630. Now, and then I've got 18 times 4x plus 11. So what I'm going to do now is I'm going to distribute. You can hear the little footsteps of my little children. So 4 times 18 is 72, so I've got 72x plus 198. My next step is going to be the subtraction, so I'm going to subtract 198 from both sides. And again, let's use the calculator because I don't feel like thinking. And we'll come up here. So 432 is equal to 72x. So if we divide 432 by 72, we get 6. So x is 6. If I plugged 6 in here, that means I get 35. Is 15 over 18 the same as 35 over 42? And the answer is yes, you'll get the same ratio. Okay, so now let's look at, we're looking at 7 minutes here. Number 11, if QRS, and that should be similar, by the way, the little similar symbol, is similar to LMN. And remember, you match it up. That means QR goes with LM. RS goes with MN. QS goes with LN. That's how you match the sides up. What is the length of LN? Well, LN goes with QS. Well, first of all, before we can do anything, we have to find X. So let's look at some sides that we're given that can help us. Well, we know that QR matches up with LM, right? So I know 15, and I'm going to go the other way this time. I'm going to pretend like we were doing a scale factor. Image over pre-image. 15 over 5 is going to give us ln, 2x plus 5, over qs, x minus 1. Again, you could do 5 over 15 equals x minus 1 over 2x plus 5 like we did in the previous examples, but I'm doing the image over the pre-image this time. It doesn't matter as long as you match them up. 15 goes with this one, 5 goes with this one. 2x plus 5 goes with this one, x minus 1 this one. So now we're going to cross multiply because we're becoming experts at that now, and we're going to make a ridiculous looking butterfly because I like drawing pictures. So we have 15 times x minus 1 equals 5 times 2x plus 5. Okay, and I'm going to go ahead and save that for you to solve because I think you can do it now. We've done a couple of examples, and you should be able to do that. Okay, and if you have trouble with that solution, just let me know. That's number 11. Okay. All right. So then we have similarity. So let's finish the similarity here. Shortcuts to prove similarity. How do we know two triangles are similar? Well, angle, angle. Because remember, triangles that are similar have the same shape, but not necessarily the same size. Angle, side, angle. Okay. And angle, angle, side. Okay. Those are some shortcuts to prove that triangles are similar. However, do you remember we talked about why we don't need these guys? Why do we not need those? Each has two angles. What's already established here? You remember that fun question we had on all the tests? So we don't need those two. Those are already covered by this one. So which other ones can we use? Well, okay, if we want to prove two triangles are similar, we have side, 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 similarity, and side, angle, side, similarity. You don't need ASA and AAS, because if you do ASA and AAS, the two angles are already there. Now, why does that work? Some of you are going, I don't get it. How are two triangles similar? Let's take two equilateral triangles. What do we know the angles in equilateral triangles always are? They're the same, right? Wouldn't that be 60, 60, and 60? And so would this be 60, 60, and 60. So when the angles are the same, they're the same shape. But why do we only need two angles? Well, what do the angles of a triangle always add up to? 180. So if I know that two of the three angles, and let's say these two are the same and these two are the same, and they both have to add to 180, what does that mean about this one and this one? They've got to be the same too. So if you know two angles, you already know they're the same shape. Okay? So let's go down to number 12. We're almost done with this page. And I'm making a long video here because, you know, just love long videos. Determine whether the polygons are similar, and if yes, write a similarity ratio and write a similarity statement. Okay, are these similar? Well, first of all, 10 and 10 are the same, which means what about these two angles? They've got to be the same, right? And so that's x and that's x. We don't know what those are, but we know they're both the same. So let's figure out what these two are. I know that 36 plus 2x is going to equal 180. Does that make sense? Because I know these are the same. So 36, so 2x equals 144. Okay, 144. Because if I do 180 minus 36, I just want to confirm it because you know my brain doesn't work sometimes. I get 144. If I divide by 2, x is equal to 72. Now, that means you've got 36, 72, and 72, and if you check that out, they add to 180. So, in order for these to be similar, that means they have to have the same angles. Well, look here. Those two are the same, which means if that's 62, that's got to be 62, right? And 62 plus y, whatever this angle is, 124 plus y, has to equal 180, right? These two plus this one have to equal 180 degrees. Well, you've got 124, okay, and that's going to be 56. You've got 36, 72, and 72, and you've got 56, 62, and 62. So no, these guys are not similar. So you don't have to fill out any of this. They're not the same shape. They don't have the same angles. So let's look at the other guy. If I look over here, that's 101 and that's 101. These two angles are the same. Again, so if I have a 101 and a 101 and an x and an x, doesn't that mean the third angle has to be the same? Yes. Angle applies here. Okay? It says write the similarity ratio and the similarity statement. We know they're similar by angle because the 101 and the 101 are the same, and that are indicated the same. Now, what's the ratio? Well, let's match up the ratio. We have to look around. So what is around the 101? And I've drawn all over it. So 10 goes with 15. Okay. 10 goes with 15. Do you see how they're both on that side of the 101? And 12 goes with 18. And you really don't have to set this up because you already know they're similar. So I can take either one. I'm just verifying just to make sure. 10 out of 15 reduces to 2/3, and so does this. And if you look at 17 over 25.5, you'll get the same thing. So your ratio is 2/3. Now, it's 2 to 3, but your scale factor, K, is 3/2. Why is that? Image over pre-image. So if I wanted to do scale factor, I would have done image 18 over pre-image, image over pre-image, okay? Image over pre-image. So if we're looking for scale factor, that's what we got. But we're not doing scale factor, we're just plain old solving similarity.